MapR provides a sandbox environment that we can use as a data source within SAP Lumira to explore big data. In this example, we'll download the Sandbox for Hadoop from the MapR website and configure it for use with SAP Lumira. To advance, follow the on-screen instructions or use the viewer control. In order to download Sandbox for Hadoop, we need to log in or register for an account first. Documentation is provided to guide us in setting up and getting started. The Sandbox is several gigabytes, so it may take some time to download. Once the download is complete, we'll move the file out of the Downloads folder to a permanent location. Once the file is in its permanent location, we can open it in our desired virtualization tool. The Sandbox for Hadoop needs to be imported as a new virtual machine into the directory. It takes several minutes to import the Sandbox. Once it's imported, we can start the image. A startup script runs in the image, starting the underlying services. Once the script is complete, a unique IP address is generated for the Sandbox. We can exit the image but leave it running in the background, and navigate to the IP address to launch the MapR Sandbox for Hadoop. Additional help is provided in the side panel for the interface. We can log in using the default username and password of MapR. MapR's Sandbox for Hadoop opens with the Quick Start wizard, which allows us to configure the system and get started. Now that the Sandbox for Hadoop is running, the next step is to set up our data. In this example, we'll build a table for baseball statistics based on a couple of Excel spreadsheets with large quantities of data. First, we'll import the source spreadsheets into the file browser. The spreadsheets here were downloaded from the following location. The batting.csv file contains each player's annual statistics, while the master.csv file contains demographic data on each player. Note that the master.csv file used in this example has been edited after being downloaded to remove extra commas. This ensures that the comma-separated values are correctly parsed when the contents are loaded into columns. To recreate the edited version of the datasets, download and open the files using Microsoft Excel and then search for commas. Where commas are found, delete them and any additional values until each cell contains only one value. For example, one nickname only per player. Note that the files have been uploaded to the directory. Next, we'll switch to Hive and create temporary tables to hold the data from the CSV files. In the query editor, we can use HiveQL syntax to construct statements to create and populate the temporary tables. This query creates a new table called temp_batting. The table contains one column called call_value with a data type of string. We'll repeat the process for the master.csv file. Now we'll take a quick look at the tables we've just created. Note that the tables each contain one column and no data. Next, we'll populate the temporary tables. This query loads the data from the batting.csv file, identified by name and location in the file browser, and overwrites any data that may exist in the temporary table. We'll repeat the process for the second temporary table. Now we'll take a quick look at the data in the temporary tables. Note that the contents of the CSV file have been loaded into the single column in the table. The data is available in the second temporary table as well. Note that when a file is used to create a table, the file itself is consumed in the process. We'll take a quick look in the file browser to confirm. The files are no longer available. The next step is to create tables with individual columns for the data we want, into which we can parse the comma-separated values from the temporary tables. This query creates a new table with columns for player ID, year, team, league, home runs, runs batted in, and stolen bases. We'll repeat the process to create a new table for the master data. This query creates a table with columns for place of birth, name, weight and height, dominant hand for batting and throwing, and first and last games. Now we'll review the tables we just created. Both tables contain the columns defined in the query, but no data. Now that the tables have been created, we can parse the data from the temporary tables and load it into the new tables. The reg_exp_extract command lets us parse pieces of data out of the string of comma-separated values in the temporary table. The syntax defines where the breaks happen and in which column to place the extracted value. Now we'll repeat the process for the second table and then check the results. We could connect separately to each of the tables in SAP Lumira and then combine the two datasets in the Prepare workspace. However, in this example, we'll create a new table in Hive instead that combines the contents of both. This query creates a new table based on a select statement that copies selected columns from both tables and joins the tables on the shared player ID column. Now we'll take a look at the combined table. Now that the sandbox is configured and the tables have been created, we can acquire the dataset and create some visualizations. A list of JDBC database access drivers displays for each supported type. We need to enter the credentials for the sandbox, MapR, and define the server and port number. The server is the unique IP address generated when we started the image, while the port number for this installation is 10,000. The left pane contains a tree of the Hive directory, which includes all available databases and tables. We'll navigate to and add the appropriate table to the query. Once we've selected the table, the query text box displays the corresponding select statement. If desired, we could modify the statement to limit the results. We can now preview the values for the default statement. A dataset is generated for the table, and all integers are automatically converted to measures with an aggregation type of sum. For these particular measures, max, min, or average are more appropriate. We can change the aggregation type using the secondary menu. Now we can create a couple of simple visualizations to test the data. First, we'll create a column chart that shows the highest RBI by team. Now we'll create a line chart showing highest RBI over time. From here, we can analyze the data in Hadoop further according to our needs, explore other data sources, or create storyboards and infographics to act as dashboards for other users. For more details on how to prepare data, build visualizations, compose infographics and storyboards, and share content with other users, refer to the full list of SAP Lumira tutorials on the SCN. Visit www.saplumira.com for more information and to download SAP Lumira free today.